You know, if you've ever read C.S. Lewis's The Chronicles of Narnia, you definitely remember the wood between the worlds. It's this quiet, kind of dreamlike forest with all these pools leading to different universes. It just feels like pure classic magic. But what if it wasn't? What if you could actually build it using math? Well, that's what we're going to do. We're about to dive into a formal paper that lays out the exact logical blueprint for this magical place.
Right, this is the big idea right here. We're going to strip away all the magical feelings and replace them with cold, hard mathematical axioms. Why? To see if this fantasy concept isn't just, possible, but maybe a necessary logical reality. It's a pretty wild thought, and it kind of forces you to rethink the whole nature of connection itself.
Okay, so first, let's just get the picture clear in our heads again. C.S. Lewis described this place as super tranquil, almost silent. You don't hear birds, there's no wind, just this thick, sleepy air. And all around are these pools of water. And every single one is a portal, a gateway to a totally different world, like Narnia or even our world.
And now, this is where we pivot from literature to logic. This whole explainer is built around a paper called The Wood Between Worlds as a Universal Liminal Object. And yeah, that's a mouthful, but it's basically a serious attempt to define this magical place using a branch of math called category theory. Now, don't worry about that term. All you need to know is it's the math of systems and the connections, or maps, between them.
So if you're going to build anything with math, you have to define your building blocks with absolute precision. No more fuzzy, magical ideas. We need to nail down exactly what a world is and what a portal is in the language of logic.
All right, here's our first formal definition. A world is what the paper calls a nucleus, basically a self-contained system. Now, the really cool part here is this phrase, quasi-crystalline structure. I know, it sounds super complex, but it's such a brilliant choice of words. It just means that every world has its own set of rich, non-repeating rules, kind of like its own unique laws of physics. It's a place with deep, intricate complexity that isn't just random.
Okay, so if a world is a place of maximum complexity, a whole is its total opposite. It's a specific spot where all those unique, complicated rules are deliberately stripped away. The fancy patterns just collapse into something way, way simpler. You can think of it like a neutral zone, a little pocket of pure simplicity inside a universe of complexity. And that simplicity, that's the secret to making a gateway.
And boom, here's how the math snaps right back to the magic. Those pools of water from the Narnia story, those are the holes. They can only work as portals because they are points where the structure breaks down. See, you can't just step from one set of complex physical laws directly into another. It wouldn't work. You have to pass through a simplified, neutral space first, a degenerate zone, to make that transition.
Okay, so we've got our two main parts, the complex worlds and the simple holes. Now we need the actual blueprint for the forest itself. The paper lays out three fundamental rules, or axioms, that this connecting space has to obey.
These three rules are everything. First up, isotropy. This means the wood is perfectly uniform. No landmarks, no special paths. Everywhere you stand looks exactly the same as everywhere else. Second, pool degeneration. We just covered this one. Every single pool is a hole, a point of total simplicity. And third, boundary-driven. This one is fascinating. Your whole journey is decided the instant you touch the edge of a pool. What happens inside the portal is irrelevant. It's all about which boundary you cross.
Now, this is the actual math speak from the paper for that first rule, isotropy. And yeah, it definitely looks intimidating, but let's just crack it open real quick. Ought of WD is just all the ways you can shift or rotate the wood without really changing it. It's symmetries. And ax transitively just means that for any 2 points in the forest, there's a symmetry that can slide one point over to the other. It's the mathematician's airtight way of saying this place is completely, perfectly uniform.
All right, so we have our building blocks and we have the rules they have to follow. And this is where things get really profound. Because when you put these axioms together, the wood isn't just a place that connects worlds. No, it becomes something much, much bigger.
Think about it this way. You could probably build a custom connection between two specific worlds, right? Some complicated, one-off bridge designed just for them. But what the paper argues is that the wood is fundamentally different. It's not some messy, specific solution. It is the universal and most elegant one. It is the single most efficient structure for connecting every possible world that could ever exist.
And this right here is the formal statement for that idea. The paper calls it the universal mediating property, and it is the absolute heart of the whole argument. In plain English, it says that for any other bridge or portal you try to build between worlds, there's a unique,
guaranteed map showing how your little creation is just a part of the bigger structure of the wood.
Let's just rephrase that to be crystal clear. What this means is that any other way you try to travel between worlds is, mathematically speaking, just a detour. All paths, all wormholes, all portals, they all eventually have to factor through the wood. It is the canonical, unavoidable intersection of the entire multiverse. And the logical conclusion from that universal property is just staggering. And it's represented by this single number. If a perfect universal connector like this exists, there can only be one, not two, not a million competing systems, a single, unique wood between the worlds, defined only by its perfect symmetry. Its existence becomes a mathematical necessity. So, let's take one final step back. We've gone from a fantasy story to formal logic, and we've landed on this unique, universal structure. So, what are the big takeaways from all of this? What does the shape of connection actually look like?
Well, here are the big consequences of this whole logical exercise. First, minimality. The best ultimate connector has no complex features of its own. It has to be as simple as possible. Second, universality. Any other connection you can think of is just a specific case of traveling through this one fundamental space. Third, boundary primacy. Connection is a surface-level thing. It happens at the edges of things, not deep inside. And finally, inevitability. If you want a universal connector that follows these rules, this is the only possible structure it can have. It's not a choice, it's necessary.
And that's really why this all matters, you know? This isn't just a fun game with a children's story. It's a really deep exploration of connection itself. How do complex, isolated systems ever interact with each other? This paper suggests that the most fundamental way isn't with another complex system, but with one that is profoundly simple and totally universal.
And that kind of leaves us with this final thought to chew on. The logic of this paper forces us toward a connector that's minimal, uniform, and stripped of anything unique. So what if that's a universal principle? What if, for any complex problem of connection, whether it's in technology, biology, or even in society, the most powerful and elegant solution isn't to build a more complicated bridge, but to find the simple, empty space that connects everything?